Hello, my name's Tony Owen from Tony Owen Partners, and it's lunchtime on a beautiful sunny day in Sydney, Australia, and welcome to our talk about facades. Tony Owen Partners specialises in 3D based digital parametric architecture in a commercial application, and a lot of that has to do with coming up with exciting contemporary facades, but more importantly how we can do that affordably and also commercially. Our commitment to facades starts with an understanding that we are in a time of environmental critical time where the resources that we rely on are becoming scarcer and scarcer while the population is ever increasing. And if we don't do something about it, very soon we'll find that we're no longer able to live sustainably. We're also fortunate in a time when we have at our resources a number of new technologies, particularly in architecture. I show this slide as an example of the F-117 fighter, which was designed in the 70s as a stealth fighter when the technology hadn't really caught up to the objectives. Whereas years later, the B-1 bomber uses technology that can actually identify the radar signatures on not a foot-by-foot basis, but a millimetre-by-millimetre basis. And so the angles have become curves. As our technology becomes more and more sophisticated, we're able to use this technology to respond both parametrically, but also in our manufacturing techniques. So here you can see what we do a lot of, which is a just-in-time manufacturing process where we're able to send our computer files to be fabricated, often in different countries like China. And this is an example from Zaha Hadid, which then can come to site even though it's fabricated in another country and fit together perfectly and get a beautiful result. So I'd like to start with the first project where we apply our 3D digital technology to facade technology and come up with interesting, exciting designs on a project called ELIZA. Now, ELIZA is located here in Elizabeth Street in the centre of Sydney, opposite Hyde Park, a very famous park. We use our parametric designs to identify that there are different views from different levels, and accordingly we have also different sun orientations. So the shape of the building at each level changes parametrically depending on what the views are, what the sun is, etc. So we ended up with, and you can see here you've got on lower levels we have a pair of units with one shape floor plate, and as you get higher up a single unit per floor with better views and different orientated views, so you get a different shape. So the model that resulted from this reflects the fact that the conditions at one level are quite different to another level. And we then use the 3D digital software to identify how we fabricate this. And this starts on the right with the shape. We then do some analysis of the different curvatures and therefore the different stresses in the facade. And then we we standardize this, and that results in the panel package. And this then goes on for a more sophisticated Rhino model. So this facade was actually documented in Rhino. And you can see an example here of looking at the different stresses on the facade and the different curvatures. So what we're trying to do is use the technology to take a complex facade and actually make it a lot simpler to build. So we're trying to, in the design development process, take out the randomness and add some rationality. In this case, we look at the curvature on the point of contraflexure here, and so we can have as much standardization in these panels as possible, whilst it appearing to be quite random. In fact, it isn't. And this carries through to a one-to-one prototype which was prepared, and this was carried further in the Rhino model, and that was actually a model of the podium, which is done in sandstone. This sandstone was actually again created as a one-to-one prototype with some sophisticated steel work. In this case, Gary Technologies helped us with the facade engineering. It's actually, the stone itself is cut out by robots according to our files, and so it fits together perfectly. So here you see the resultant facade. It's both a very contemporary facade, but also fits into a fairly historic precinct, which has a lot of heritage buildings alongside of it with the stone. So it's at once a heritage response, which is quite contextual, but at the same time very contemporary. And this is our approach, using the technology to solve problems in the real world. Here you can see the building as it sits next to Hyde Park, and as it fits in with the context of the environment and the buildings. You can see there's a podium here which has a 4-story stone podium, laser cut stone, and the entry canopy as well, which creates a very beautiful and luxurious entry to what is a very high-end apartment building. And as you get toward the top, you see the sculpting of the forms in metal panel and stone. And this is the view at the daytime. This is a 3-story penthouse towards the top. There's a light well inside which has a green wall, and we use the same technology when we were sculpting the lobby. So the lobby is also in laser cut sandstone. We used digital technology to coordinate the surfaces, and ultimately resulted in a very beautiful and luxurious entry, but also very contemporary. And you can see the expression on the balconies, which is using sun shading devices and very high level of finish, both internally here with the fireplace and the main living area, and as you see here, and as we go through to the entry lobbies per level, where we're again echoing the geometry of the facade, the bathrooms, as you see, and this is the main penthouse bathroom, and the main penthouse kitchen, which enjoys light from both sides. So that's the ELIZA project. Another project which we used some similar techniques in what we call radical pragmatism, where we take problems on the site and try to solve them very pragmatically, yet at the same time producing some very extraordinary results. This is a site in, again, a historical part of the city, where we were heavily overshadowed by other buildings. Now in Sydney, the regulations and controls make it very difficult to have residential uses where you have very little sunlight. In this case, we had very little sunlight. So under normal circumstances, without the technology, we simply couldn't have an apartment building on this site. However, what we did was we looked very carefully about where the sun was coming in to try and maximize it. So you can see here we started mapping the angle that the sun was coming at different times of the day and where it was hitting the facade. This actually included reflected light from other buildings as well. And at different times of the day, the sun would have a different angle, both in the horizontal plane, but also in the vertical plane as well. So what we ended up doing was mapping on the facade where you got the most sun at a different time of day, and then angling the windows both horizontally and vertically to capture the most amount of sun when the sun was hitting that facade at its strongest. So we ended up with a facade where every window had a different angle, and that angle was specifically mapped and designed according to the maximum sun. We then turned this into a set of construction drawings, and again these were fabricated overseas and imported and fit together in Australia. So using the technology to ensure that prefabricated and remotely fabricated components come together and fit together perfectly. And we use some fairly extensive packages in order to convey that information. And the resultant building is both beautiful but highly practical, and that allowed us to get residential uses on a site where ordinarily you couldn't. So you can see here you have a brick podium reflecting the masonry character of the surrounding buildings, and then our Suncatcher facade, which also became a very beautiful facade with coloured panels, and we ended up calling this building Mosaic. And you can see at night time, from the different angles, you would get a completely different picture. Here, the coloured panels on the angled bay windows reflects a much more coloured facade, and you can see that during the daytime as well. But from different angles, it's quite an open facade. And this was an extremely successful and also very beautiful building. And so you can see the technology driving the facade and pushing the technology to get a very pragmatic but very radical result. And you can see the relationship in the brick podium to the surrounding historic buildings. Here you can see internally the way these angled windows floods the unit with light, both in the bedroom here and the living room. We applied the same technology to the podium, where we took the surrounding building's brick podium we incorporated exactly the same geometric response and then applied the technology to allow the simplest, most affordable fabrication. So here you can see the podium facade, which reflects the pattern of the surroundings, yet also reflects the geometry of the building as a whole. And at night it becomes also a very beautiful addition to the streetscape, as does the whole building. In the lobbies we juxtapose off-form concrete with also some light ceilings to allow light into a reasonably dark part of town, and also reflecting the outer facade with the light wall also in the sandstone, the cafe as well. Here's the cafe, as you can see. So a very successful project. Another project where we took our idea of radical pragmatism and digital technology was a suburban house in Sydney, enjoying some views, and we looked at various different models in order to generate the idea for this facade. And ultimately we often use a real-time model such as this, which we can stop at any time, in order to explore different geometric solutions. In this case we were balancing issues such as sharing of views between different buildings, and also maximizing ventilation and through-site links as well. And we ultimately resulted in into this model. This actually became a shell where we clad the whole building in metal panels, and so it ultimately became akin to an automobile construction system, where we had the frame on the inside and then the various components and cladding that went on the outside. And here's the cladding. So ultimately what we had was an internal frame and a cladding on the outside, where we had a 300mm zone for services which had to be millimeter perfect. And you can see we had a lot of curved concrete, and this is the formwork, so it was a very exciting construction phase, as you can see. And also here's the frame being assembled on site, and ultimately the cladding, and you can see the 300mm services zone here. And this then carried through to the building itself, which is clad in aluminium panels and is very beautiful. So the geometry was actually determined in terms of maximizing views, sharing of views, maximizing natural airflow, and maximizing overshadowing and light as well. So this millimeter by millimeter use of the 3D technology to maximize the efficiency of the building, but ultimately have a very beautiful sculpture as well. And you can see here the street facade of the building, and looking at the at night time, looking at the rear of the building. Internally, a very beautiful and luxurious space as well, with the curved walls. Here we see the kitchen with the butler's pantry and the furniture inside. So a very nice open plan family home that works really beautifully. Here's the kitchen. It works really beautifully environmentally and doesn't need air conditioning, and really maximizes the beautiful views of Sydney Harbour. Here's a stair which we designed, which was then fabricated in China, and came to site and was assembled on site. And here you can see Sydney Harbour and the Opera House in the background. Another building where we utilised this technology was Bill's House. Now, Bill's House here, I won't go into this one in detail, but it was generated from the Mediterranean background of the client, and this was the sails on the Mediterranean harbour. And this became a really beautiful sail house, again using steel technology internally, and panels and render on the outside. The central staircase you can see there, and the outdoor spaces make it a really beautiful environment to live in. This is the main entry lobby, the main living area with the rough stone against the sophisticated technology of the geometries. Again, an open plan bathroom. Okay, so here's a project in Sydney which is located on a main highway and a railway track. Here's the railway line, and the side of the building is here, so it enjoys a lot of views, but it's also very visible to a lot of people. we use the environmental principles of the site. There's a central space in the middle and balconies and buildings all the way around. What that allowed for is naturally ventilation coming through the building to minimise heat gain, to minimise energy use. We here explored the notion of really celebrating the balcony as an outdoor space in the Sydney climate. And we also thought, well, how do we deliver this exciting facade and this technology very affordably? And what we did was we broke it down into effectively two components. We have the stick, or the long piece, which was always the same, and the node. So you had basically 1, 2, 3 elements, and that was repeated, allowing this entire facade to be built for basically the same as a normal facade. And you can see here that this element and this element are always identical, and this is the same. So in fact, there's only 2 elements, and these would come together using a component. Now, ordinarily, when something like this is done, you would have to have, framing, and you'd have to have panels and insulation. In fact, each of these pieces was a single aluminium extrusion, significantly reducing the cost of this element. And so we're constantly trying to come up with these exciting ideas and figure out how do we build them really affordably and cheaply, that they could then be assembled on site like this by a single person. And this is ultimately the building, and it was very successful. It's called Alpha, and we had a lot of fun with this one. And you can see the real celebration of the indoor-outdoor space here, and also something that's visually very exciting in the surrounding areas. You can see the street facade now and how it's activating the local environment in the daytime and also at night time. We also applied the same technology to what we called sky houses. So the upper 2 floors were 2-story loft units. This is a real photo, not a render, showing how it relates to the surrounding areas, and you get this fabulous double height space. And the central atrium allowing for natural ventilation, and lounge areas for circulation zones. Another one, this is also in the city, where we had a brief to design some student housing. Again, the trick is to maximise the surface area and the yield, which is natural light, but maximising privacy. We took the sites and we divided up into a series of smaller slices, as you can see here. Now, normally this wouldn't be allowed, and what we're trying to do is to get all of the rooms to have an external view. So we're increasing our surface area threefold, but allowing for each of the individual rooms for the student housing to have light, but also privacy. So you can see the light is able to come in, and also the ventilation. Again, we had a 9-story atrium to allow natural ventilation via glass louvers. So the airflow works very well as it comes up through the building using the Venturi effect. But at the same time, we're trying to maximize privacy by not allowing people to look into each other's views. And we ended up using these window boxes here. And this was very successful. And what you can see is that everybody gets a view, everybody gets sun, but nobody can see each other. And you get this really interesting dynamic and really sculptural play of light within these cabins within the building. And of course, the glass louvers allowing natural airflow throughout the building. So here you see that privacy working with somebody at their desk, and also at night time it's lit up in a very beautiful way. Here's a standard room. We have 4 rooms off a standard lounge area, and the central atrium, and included a number of common facilities and theatres in the basement with access to light down through these shafts, which was ultimately built, as you can see. And the cafe, the geometry is carrying through, in this case, to the cafe as well. Another building which was all about how it presents to its context and environment is what ultimately became known as Eden Art Hall. As you can see, a very public part of the city. In this case, we tried various different geometries, and we played around with the idea of the building as billboard. So what we did was we looked at various different pieces of art, we pixelated them, and actually had an online competition which people voted on. and ultimately selected this fabric pattern, which was then pixelated and turned into the facade of the building. And this is the eastern facade with a lot of circulation, so it became a sunscreen. And we used a palette of six different colours. So again, how do we realise this project affordably but also very beautifully? And you can see using two-storey units how we maximise the circulation at the rear and the public spaces at the front. And this was ultimately the building, which really presents a very positive piece of art to its environment, using a limited palette of colours to transcend the norm, using the technology to do something special. And this carries through here, as you can see, to the rest of the project. And this is the street facade, which is a little bit more subdued and sedate with the public areas. And here's a typical example of a living room. This is a project with a similar concept to the facade, where we have a site in Brisbane with oblique views to the city. So what we're trying to do is, here's the site, to maximise the views in this direction. So what we did was we angled all of the units out to grab as much view as possible. And here again, the idea that on every level the view character is different. So ultimately we plotted those parametrically to determine where the windows and the building would come out and where it would recede. And we modelled that in 3D and also using 3D printing. And this is ultimately the building that resulted. It's called the Melbourne Residences in Brisbane. There's a 4-storey podium as well, which has retail and actually parking behind. And it's become a really exciting part of the Brisbane CBD. And you can see how the windows are stepping out here to maximise views. We used a similar idea of this undulating pattern in the retail podium, which ultimately has a series of layered wave patterns to also mask the parking, and that's actually carried through here as well. The laneway at the rear was further activated, and we envisaged a retail activation of what was a very poor laneway, and that's ultimately been very successful as well. You can see this carries through to the entry lobby, which has a green wall, very inviting high-end finishes, through to the units themselves with the mirrored island bench and the very spacious units where you can see those views coming in. And they do love their roof terraces in Brisbane, so the club-like environments on the roof with swimming pools, gyms and activation are very important as well. An interesting project for us in terms of uses as well as facades was the Abu Dhabi Ladies Club in Abu Dhabi. This is the men's club, an officers club, and they wanted a similar club for ladies. This was the site, and it's effectively a $100 million spa, but it has education facilities, museums, conference facilities, sporting facilities. Our initial idea was the flower, which you can see carrying through here, that resulted in the ultimate master plan with its own beach, protected of course with a series of view screens, swimming pools, indoor sports facilities, etc. It has indoor swimming pools, it has indoor courts. We then used an L system for a branching petal-like system for the facade. As you can see here, you can see the petals being reflected and the shade canopies as well. And ultimately this was built. This is some recent photos of it with the entry canopy and the sandstone facade with the petal-like patterning, which then carries through to the privacy-protected internal swimming pools, the entrance again, and the main reception area here at night time, and the main pool areas here protected as well, and ultimately the lobby. A project in Mooloolaba on the Gold Coast in Sydney, where we took as our inspiration the estuarine patterns on the water caused by the tidal conditions, and reflected that in the massing of the building. But it's also about, again, very practical solutions to maximising views to the facades, which ultimately ended up in this building here. Now what you see is, a solid facade, but becoming less solid as you get to maximise the views. Now sometimes those undulations are concrete, and sometimes they're, as you see here, perforated mesh. So you still get a view, but also allow the massing and the modelling to occur. And that's fairly imperceptible. So again, really practical solutions, very buildable solutions, but also very beautiful solutions. So this is, and you can see the transition from solid to semi-opaque. So this is a building that's a sculptural addition to the coastline that maximizes views and creates some very beautiful external internal spaces. This is the main lobby, very beachy, and these are the decks, which have double height decks because we alternated the balcony from one side to the other, so we get these double height spaces but also get sun protection. A building which is very much a facade project is the Dank Street project, which is actually a refurb of an existing 3-story masonry warehouse building, so a very dull, very solid building, which we ultimately put again a central atrium in to allow natural ventilation, and we put some steel balconies on the outside. So here you can see the atrium being created within what was a very solid building, and you can see applying a metal screen to the new aluminium balconies, as you can see here. Now in this case we looked at a twisted skin. We used just an alpolic, but put a twist in it to allow for strength. And this allowed us to find a very affordable but also very beautiful solution. Again, you can see here using the geometry to maximize the expression of the building. There was actually there's a supermarket on the ground floor and commercial buildings above. It's proven to be an extremely successful building, with a lot of the shops doing extremely well, and also it's really led to rejuvenation of this part of the town where commercial wasn't really seen to be viable before, but we created this destination building, a really iconic solution here. And the facade very much a part of that. But again, our affordable solution using the existing floors, all the existing internals. Here's that lobby again, but again just basically cladding in glass with some stickers on it. So, and some very basic interiors to create a really beautiful light-filled space. That's basically paint on the walls, and you can see how the external geometry and the internal geometry is carried through using either paint or, in this case, a wall finish, painted ceilings, and in fact this is the patterning on the glass, which is the corporate ID for the building as well, and the twisted louver fins. A building that's been going on for a very long time in a historical part of the city called Paddington and Oxford Street. This was a fairly famous site with a church which is famous for its Saturday markets across a plaza to our site here. So we had a strong contextual relationship between these two buildings. And what we did was we looked at the geometry of this building as a church and broke it down into its buttress geometry. And that sort of led to the articulation of the massing, and this was further developed and articulated in sandstone, leading to a building which had a ground floor retail and 2 levels of apartments. And this was ultimately the facade, which reflects the context along Oxford Street, but also its relationship to the church as a residential commercial building in the context of its historic setting. You can see 1, 2, 3, 4 units with a central core, and the facade reflecting either a solid element being the bedrooms or the open elements being balconies or stairs. A very operable facade with screens and windows that open in this triangular form, and of course the celebration of the street retail with the canopy. This has taken a very long process to build. You can see the initial steel work for the facade carrying through, which was then clad in stone or glass as we went along. And these are some recent pictures, still not finished, largely because of some issues with the builder. and each of these joints is an LED as well, so at night it's going to be fantastic. So you can see the solid elements, which are a combination of sandstone, glass, and perforated mesh panel, and the operable balcony zones as well. And so this was a few weeks ago, and it's really going to be very nice. And then a few days ago, where we started to see the canopy come on board, so we're very excited for that one. And inside you get this really sort of fractal approach to the inside-outside. Another building where we looked at the idea of privacy, a very dense area for a residential project. As you can see here, very tree-lined. What we did was we had a U-shaped building with a courtyard in the middle. There was a lot of issues of privacy to the neighbours, and we were required to do a lot of screening. The U-shaped design allows for natural ventilation, and you can see here where a lot of the facade has external walkways and screening. This is the street facade, where the screening itself created the geometry or the identity for the building. We used what we call an origami screen here, which was a perforated aluminium screen folded to address the both the functionality of it as well as the decorative aspects of it. And these alternated in different bays. And this ultimately is the internal courtyard, which in some cases has balconies. In this case, it's a walkway, allowing the wings to be quite close together, but also to have privacy, and also a very beautiful sculptural zone. So this is the central courtyard through here. These are living areas, and these are circulation walkways. You can see at dusk. So the offset between the the concrete, the in situ concrete, and the very delicate screening to the courtyard. And this is expressed on the outside as well. Now we introduced a very interesting balustrade here, which actually angles in two directions, and then the metal panel framing, which results in a really interesting dynamic in the building, creating a very strong identity, and it's been extremely successful. Here you can see the walkway with the screening on the outside, which creates a degree of privacy, and all of the nodal points, such as the stairs, articulated using the same aluminium elements that frames up views. Here you can see the geometry of the balustrades, and that carries through to the working drawings again. How do you realize and this was not done in steel but aluminium, which is a lot cheaper, and basically it's a single element with a bend in it. The leftover pieces became a sculpture. So again, very practical, very pragmatic solutions to allow a very affordable building that transcends the norm. Another building where we did a similar thing, very affordable tower in this case, just alternating between a solid concrete balustrade and a glass balustrade to create a very dynamic and sculptural effect that transcends the norm. So this is a building in near Sydney Airport. Building in Parramatta, satellite city in Sydney, where we had a corner expression with a series of units around a central core, fairly normal situation. In this case, we had to deal with a lot of issues relating to heritage and public art. It's actually, again, a historical part of the city. Excuse me. And what we did as part of the public art component is we tracked the historical grid pattern of the city and the public spaces onto the new grid pattern, which was a later grid pattern, and actually applied that to the whole facade as public art. And then the fun was getting the technology to work. A similar idea is that Alpha apartment, where we used a single aluminium extrusion and a nodal point, although in this case every node was different, and it wraps around the building. So a development on the previous technology, and you can see here a node and a flat element, so whilst it's a single extrusion here, it did sometimes have a curd, and each one was different. These ended up being some quite large elements fabricated in China and imported, flat packed, and ultimately went on the building. So this was extremely successful. It all fit together based on the precision of our drawings. At night time as well, it's become quite an icon in the area, and you get these really interesting spatial relationships on balconies. You can see in the daytime, at night time, and from above, and of course carrying through to the lobby as well. So that's it. I hope you've enjoyed our presentation about how we use 3D digital technology to realize commercial projects that transform the norm. Thank you very much for listening, and I hope you enjoyed it.